Given question, draw shear force diagram and bending moment diagram when internal hinge is provided.
Beam is supported at 3 points A, B and C. Internal hinge is provided in the system at point D. Beam is having uniformly distributed load 10.1 kN per meter all over its length. And we have to draw the shear force diagram and bending moment diagram, and the condition is that hinge is provided at point D. So when the hinge is provided, that point bending moment is equal to 0. Hinge can transfer only axial forces and lateral forces. So to draw free body diagram, we have to make the two parts of the given system at the point of hinge. So first part will be path A, B, D and second part path DC. Now we will understand how to draw the free body diagram. So we will first consider this point D. So in the first part there is path A, B, D. So here is the point D. And in second part here is the point DC. Now at point D, this point is the hinge point where the axial forces and lateral forces are transferred. So we have to show the forces which are in opposite direction but equal in magnitude. So we will first show vertical force. So vertical force for the second part I will show in upward direction, and its a magnitude we will show as a dy. Then in the first part we have to show the force with same magnitude but opposite in direction, that is dy. Now we have to show the horizontal force. So here also same condition, equal in magnitude but opposite in direction. So its a magnitude is dx for both these components. Now in the first part, if we observe, there is uniformly distributed load. So this uniformly distributed load is equal to 10.1 kilonewton for 1 meter. But what is the total length? Total length is 8 plus 2, that is 10 meters. So for 10 meter, how to calculate its a magnitude? So here cross multiplication. So 10.1 multiplied by 10 divided by 1, that is equal to 100 kilonewton. So we will that is total load for the first part is equal to 100 kilonewton. Now here is the point of application for this load. So it is the center point of the first part. So center point, that means 10 divided by 2, that is 5 meters. So we will select here one point and we will mention 100 kilonewton, and it is at a distance 5 meter from A and 5 meter from point D. Now in the same way we have to mention the uniformly distributed load for the second part DC. So here total length is 8 meters, so middle point is at 4 meters. Now how to calculate the total load? So it is 10.1 kilonewton for 1 meter and total length is 8 meter. So for 8 meter, how to calculate this? That is 80 divided by 1. So we have to take here as a 80 kilonewton. Now these are the support points at A, B, C. So we have to show the reaction at these points, that is RA, RB, RC. Now from the free body diagram we have to find out the unknown terms. So which are the unknown terms? RA, RB, RC as well as the vertical load at point D. Because when to calculate the shear force diagram, we require to find out this vertical load at the hinge point D. So it is necessary to find out the magnitude of dy. Now we will take the second part, that is part DC. We will consider this part will be in equilibrium. Then we can say that summation of all vertical forces is equal to 0. Now if we observe, these two D and C are the end points, and at end points two supports are given where the reaction is in vertically upward direction. So we can say that this will act as a simply supported beam. Now from this diagram, how to write? So we will write here as dy plus RC is equal to 80. So because this is the simply supported beam, this 80 kilonewton load will be equally distributed at these two end points. So we can say that dy is equal to RC is equal to 40 kilonewton. So here this is the value of dy. So I will mention here dy is equal to 40. So in the first part also magnitude is equal. So we will write here the value 40. Now we will move to the first part, that is part A, B, D. Now again we will take the summation of all vertical forces is equal to 0. So here RA plus RB, because these are in upward direction, is equal to 100 plus 40, that is equal to 140. So we will get the equation number 1, that is RA plus RB is equal to 140 kilonewton. Now we will take summation of moment of all forces about point A is equal to 0. So how to take this moment? So for that we will first decide the sign convention. So for the clockwise direction we will take positive sign, and for anti-clockwise direction we will take the negative sign. So if I move the compass in the direction of 100 kilonewton, then it is in clockwise direction. So how to take moment? 100 multiplied by this distance is 5. Then if I move the compass in the direction of RB about point A, then it is in anti-clockwise direction. So minus RB multiplied by 8. Then in the direction of dy it is clockwise, so plus dy into total distance is 10. So it is equal to 0. So we have to solve this. So this unknown term RB we will transfer to the right hand side, and when we put the value, then we will get the value of RB 112.5 kilonewton. So this is the equation number 2. Now if we move from second to the first, that if we put the value of this RB in the equation number 1, then we will get RA is equal to 27.5. So we will mention here. Here is 27.5, 112.5, and RC is equal to 40. Next step is to calculate the shear forces at different points. So it is the summation of forces either on the right hand side or on the left hand side, and we are going to use the sign conventions. For this question we will take the summation of forces which are on the right hand side. So if on right hand side force is in downward direction, use positive sign, and if the force is in the upward direction, use negative sign. Now we will consider the second part DC. So I will write here part DC. We will take the shear force at point C. Now if we observe at point C, there is point load as well as uniformly distributed load. So whenever at a single point there are two types of load, then we have to consider 2 points. That is, one point is on right hand side and other point is on left hand side. Now if I take the right hand side, that is the immediate point on the right side of C, then there is no any force on the right hand side. So shear force is equal to 0. But if I take the left hand side, then we get here the point load, and which is equal to 40. But it is in upward direction, so take the sign minus 40. Now in the same way, shear force at point D. So at point D there is the point load as well as uniformly distributed load. So we will take the right hand side and left hand side. So we have to mention these sides also, that is right and left. Now if I mark one point at a right hand side, so on right hand side of D there are only 2 point loads. Sorry, this is uniformly distributed load, so it is in upward direction. So use negative sign, that is minus 40. and this is in downward direction plus 80, so which is equal to plus 40. Now on left hand side of D there are three types of loads. So we will use here on left hand side this force is in upward direction. So use negative sign, minus 40 plus 80 minus 40, that is equal to 0. Now we will move to the part ABD, that is the first part. So we have to mention here. Now again we will use here at point D there is the point load as well as uniformly distributed load. So SF at D. So we have to take right hand side and left hand side. So on right hand side, if I consider here immediate right hand side, there is no any load because this is the separate part. So on right hand side it is 0 and on left hand side it is in downward direction. So if we observe for downward direction we have to use the positive sign. So on left hand side it is plus 40. Now SF at point B. Now this is important point. Now we have to mention here uniformly distributed load for this part BD. Because on BD if we observe there is uniformly distributed load. So its a total length for this part is 2 meters. So what is the total load? So it is 10.1 multiplied by 2, that is 20. So we have to mention here 20 kilonewton at the middle point. Here I will mention 20 kilonewton at the middle point. Now shear force at point B. So point B is carrying uniformly distributed load as well as point load. So I will write here two types, right side and left side. So on right side if I consider here one point, there are two types of load and which are in vertically downward direction. So what is its a value? Its a value is 40 plus 20, that is equal to 60. So I will write here 40 plus 20, that is equal to 60. And on left side if I consider here one point, then there are three types of load, 40 plus 20 minus 112.5. 40 plus 20 minus 112.5. So we have to write here the. To calculate shear force at point A, if we move to the part AB, then there is uniformly distributed load over a span of 8 meters. So we have to first show this load. So it is 10.1 kilonewton for 1 meter. So for total span of 8 meters, it is equal to 80 kilonewton. And we have to show this load at the middle point of this part AB. So I will show here 80 kilonewton. Now at point A, there is uniformly distributed load as well as point load. So we will consider the right hand side point and left hand side point. So at the right hand side point, what is the shear force? So we will add all these forces. So when the force is in downward direction, use positive sign. So we will first take this dy, that is equal to 4t. Then RB is in upward direction, so take minus 112.5 plus 20 plus 80. We have to calculate this. So when we calculate this, so 80 plus 20, that is equal to 100, and 140 minus 112.5. So that is equal to 27.5. Now if we move to the left hand side, then we have to add all these loads. So again these three loads we have to add, that is 80 plus 20 plus 40 minus 112.5 minus 27.5 minus 112.5 minus 27.5, and it is equal to 0. To draw shear force diagram, we have to first draw the baseline. We will plot the positive points in upward direction and negative points in downward direction. We will move from right hand side to the left hand side. So if we observe this free body diagram, then on the right hand side, that is at point C, we have to first select this right hand side point. So it is equal to 0. So we have to plot this 0 point at the baseline. Then on left hand side of this point C, it is minus 40. So minus sign, we will plot this point in the downward direction. So here is the 40. Then we will move to the point D. So if we move from this side towards the left side, then here is the point D right hand side. So point D right hand side, it is plus 40. So we will plot here the point plus 40. And then on left hand side it is 0. Now we will connect these points in the same order, that is from right hand side to the left hand side. That is first is 0, then second is minus 40 and third is plus 40. Now if we observe in the span DC, uniformly distributed load is given and therefore shear force will vary linearly. Now we will move to the second part, ABD. Now we will concentrate on this part. So again we will move from right to the left hand side. So at point D, we have to consider the right hand side point. So it is 0. Then next point is the left hand side point. So it is plus 40. So here is the plus 40. Then we will move to the point B. So on point B, there are 2 points, right hand side and left hand side. So we are going to connect from right to the left. So we have to connect, that is for B on the right hand side. So it is plus 60. So we have to connect this 40 with plus 60. So here is 60 and we will connect these 2 points. Then we will move to the left hand side. So it is minus 52.5. So we have to show on the same line because these 2 points are nearer to the point B. So on the same line I will show here 52.5 and we will connect this 60 and 52.5. Now if we move to the left hand side, then we have to select the point which is on the right hand side of point A. So it is plus 27.5. So we will show here 27.5. So we have to connect these 2 points. And then after that left hand side which is having 0. So we have to select here the value 0. We will mention it. Now we will calculate bending moment at different points. It is the summation of moment of all the forces on right hand side or on the left hand side of the selected point. We are going to use these sign conventions. We are taking the summation of moment of forces which are on the right hand side for this question. Now we know that the bending moment at the point of hinge, that is the bending moment at point D, is always equal to 0. So we will mention here Bm at point D is equal to 0. So we will mention here this is the point D and we will take this point will be 0 which is on the baseline. Now we will move to the point A. So bending moment at point A. Now if we observe this moment, if it is in clockwise direction, then use negative sign, and if it is in anti-clockwise, use positive sign. Now this 80 kilonewton, if I move the compass about point A, then it is in clockwise direction. So we will take minus 80 multiplied by distance in between 80 and point A. So it is the center point, that is 4. Now we will take this force RB. So it is in anti-clockwise direction, plus 112.5 multiplied by 8. Then we will move to the next, minus 20 multiplied by. So this is the center point. So this distance is 1. 8 plus 1, that is 9. And then this 40. So it is also in clockwise direction. So minus 40 multiplied by distance in between A and D. So it is 10. So we have to calculate this. Now we will move to the point B. So bending moment at point B. So when we calculate this, so if I move the compass in the direction of 20 kilonewton, then it is in clockwise direction. So minus 20 multiplied by distance in between B and 20, it is 1. Then minus 40 multiplied by 2. Now we will move to the next point C. Bending moment at point C. So if we observe on the right hand side there is no any force, so it is equal to 0. So calculated values of bending moment at A is equal to 0. So we will mark this point on the baseline. So here is 0. Bending moment at point B, it is minus 100. So because of negative sign, we will use on this point B, here is the downward direction, it is 100. Then bending moment at point C is 0, at point D is also equal to 0. Now if we observe shear force diagram, then there are 2 points where the value of shear force is equal to 0. So I will extend these 2 points. We know that when at the point where shear force is equal to 0, there is maximum bending moment. So this point we will consider point P, and here is the point Q. So we have to find out the value of bending moment at point P and at point Q. To find out the maximum load at point P and Q, we will consider the point P is having distance x1 from the point A and the point Q is having distance x2 from the point C. So we will draw the free body diagram. So distance in between A and this point P is equal to x1, and the distance in between point Q and C is equal to x2. Now if we observe this span AP, then here is uniformly distributed load. So how to mention the total load over the span x1? So it is 10.1 kilonewton for 1 meter. So total distance is x1. So total load is 10.1 multiplied by x1. So I will show here 10x1. Now the point of application of load is at the center point. So we will show here the center point. So we have to show this x1 by 2 and here the remaining distance x1 by 2. Now in the same way for this QC, there is uniformly distributed load. So total load is 10.1 x2. And the point of application of load is at the center point. So here x2 by 2 and x2 by 2. Now we have to find out the bending moment at point P and at point Q. So we will use this sign convention. So first I will take bending moment at a distance x1, that is at point P. So summation of moment of all the forces. So if we observe there are left hand side forces. So if the moment is in clockwise direction, use positive sign. So about point P, this reaction, that is RA, is in clockwise direction. So use positive sign. So plus 27.5 multiplied by x. Then here this 10x1 is in anti-clockwise direction. So use negative sign, minus. Now this is uniformly distributed load. So it is 10x1 multiplied by x1 by 2. That means minus 10x1 square by 2. So I will solve this 27.5 x1, sorry here not x, it is x1 minus 5 x1 square. So this is the formula to calculate the maximum bending moment. Now we will move to the next point, that is for this point Q. So again we will calculate this bending moment at point Q. So it is at a distance x2. So it is on the right hand side. We will take the summation of moments on the right hand side. So if it is in anti-clockwise direction, use positive sign, that is plus 40 multiplied by x2. And here is, it is in clockwise direction, so minus 10 x2 into x2 by 2. So it is 10 x2 square by 2. So 40 x2 minus 5 x2 square. to find out the maximum bending moment at point P and at point Q, we have to differentiate these formulas with respect to x. So here is the formula for maximum bending moment. D by dx of bending moment is equal to 0. So we will differentiate bending moment at point P with respect to x1 and we will equate it to 0. So d by dx of 27.5 x1 minus 5 x1 square is equal to 0. So how to differentiate this? So it is equal to 27.5 minus, now x1 square is having differentiation 2x1, that is 5 into 2 minus 10x1 is equal to 0, and therefore value of x1 is equal to 2.75. So this value is equal to 2.75 meter. Now in the same way we will differentiate bending moment of Q with respect to x and we will equate it to 0. So it is 4t minus 2x2 into 5, that is 10x2 is equal to 0, and therefore x2 is equal to 4. So the value of x2, that is equal to 4 meter. Now when we put the value of x1 in the formula for bending moment at point P, then we will get this value 37.81. So it is the positive value, so I will plot here 37.81, and when we put the value of x to 80 at bending moment at point Q, then we will get the value x2 value, if we put 4, then we will get bending moment value is equal to 80. So I will plot here the point 80. So this is the maximum bending moment. So how to connect these points? Now we will move from point A to the point P. Now here is uniformly distributed load. So bending moment is having parabolic curve. So I will connect with parabolic curve. Then from this point P to point B. Now here is 100, that is the minus number. So again we have to connect these 2 points. Now we have to move from this point B to point D. So for at point D it is 0. So again we have to join with parabolic curve. And then from point D to point Q, where bending moment is maximum.